As a Center for Biodiversity Research, the diversity of life is very important to the MFN. And that shows. Basically, in our collection, we have about 30 million objects altogether. And on this biodiversity wall here, we have 3,000 species altogether. And most of these are actually real. This is due to the fact that we have the taxidermy department in-house. We have our own, and we are very proud of them because they take part in contests for taxidermists worldwide, and usually they take one of the top places. And no animal has to die anymore for our exhibition. That happened centuries ago, but nowadays we have very good ties to, for example, the Berlin Zoo, to the Berlin Tierpark, and to breeding facilities worldwide. And if an animal dies there, we are usually one of the first ones to get the call, and this is how we get our animals here for the exhibition. For decades and maybe even centuries, people were wondering, why does the zebra have its stripes? And scientists concluded, well, it must be for some sort of camouflage. And even Charles Darwin weighed in, saying, well, in the flickering African heat of the Serengeti, maybe the stripes melt together into something the lion can't really grasp. The problem with this is, however, that there are still zebras being eaten by lions, so that's not too good a method. And it turns out there's an even greater enemy to the zebra than the lions, and it is this little guy, the Tsetse Fly. This little rascal can transmit serious disease, but with its compound eyes, it's having a really hard time landing on something striped, such as a zebra, preferring now more monochrome landing strips, for example, lions. See how the tables have turned? This is a bust of Charles Darwin. This now quite famous scientist from the UK was wondering, like many people before him, where does this awesome abundance of life actually come from that we are observing around us? And he came up with the revolutionary idea, the concept of evolution. He said all these different life forms originate from just one single life form and then diversed over time. And we need time, that is crucial. And then small little differences, now known as mutations, provide the basis for the diversity of life nowadays. This was revolutionary when he invented this idea and when he wrote this down in 1859 in his book On the Origin of Species by Means of Natural Selection. He has been misquoted a lot, but basically all he's saying is that all organisms on life, we're all related. If you just go back far enough, there's a common ancestor. So basically, we're all one big family. This little green fella here next to me is a Kakapo Parrot from New Zealand, and it's very near and dear to my heart. Why? Because there's only 200 of these little guys left. But this is reason to celebrate, because there used to be only 50 not too long ago. And the reason for that is the settlers introduced snakes, cats, or rats into the ecosystem, and they wreak havoc on the population of the kakapo. Because the Kakapo parrot isn't used to being hunted like this, so it just stays put. It doesn't have any instinct to run away when a predator shows up. So when a cat follows the scent of a kakapo, there's bound to be a kakapo sitting at the end of their trail, just waiting to be eaten. Now you could say, maybe that's not too bad and the kakapos can compensate for that, but not so much. They only reproduce every couple of years, and then the male produces a mating call, which is in itself a very cool idea, but the mating call of the kakapo sounds like a heartbeat from a subwoofer. It's very low. Ooh, ooh, ooh. And this is a good thing because it carries very far, but I don't know if you have a subwoofer at home. It doesn't really matter where you put it. You can't really locate it with your ears. You can hear the bass, but you don't really know where it's coming from. And this is the same with the kakapo. So the female hears the noise, but she can't really locate the male. And that leads to very frustrated males. And there are even camera tapes showing a male trying to reproduce with the cameraman, or even a rolled up sweater on the ground. Nowadays, people try to help them with their reproduction in breeding facilities in New Zealand. So maybe not all is lost for the kakapo. So right here we have a Tasmanian tiger, and as far as we know, these guys are extinct. There's not one living Tasmanian tiger left. With the tiger, it shares basically only the stripes on the back, because it's more closely related to a kangaroo or a koala, for example, because it's a marsupial. It has a pouch. So it's a mammal, but it's a marsupial because it lived in Australia. The reason for the extinction, well, there's plenty of reasons basically, because people started hunting them. People also introduced dogs and feral dogs into the environment that basically took away the space or the habitat of our Tasmanian tigers. And also they were prone to viral infections of these dogs. So you can vaccinate your dog, but nobody vaccinated the Tasmanian tigers. So it is quite a sad thing because these are brilliant and beautiful animals. And the last one that we know of died in 1936 in the zoo in Hobart on Tasmania. So if you find a Tasmanian tiger today or traces of it and can prove that there's one alive, you're basically getting about €1 million for your find. So what are you waiting for? As biologists, we want to make our life easy and we want to classify pretty much everything. For example, in animals, we are looking for differences between the animal groups. So if one group has a difference that no other group has and it doesn't share with anything else, then that is an apomorphy. And if you find these apomorphies, that helps us greatly. And as an example, I have an echidna and a platypus here. They are mammals like we humans are. However, they produce eggs, unlike us. But what makes them mammals is that they have mammary glands, so they feed their young with milk. And it's exactly apomorphies like this that help us greatly in classifying everything around us.